In this tutorial, we'll be exploring um, the approach of guessing parameter values for a simple linear regression model. We will also see how to calculate the corresponding loss and visualize it. And finally, we'll also explore gradient descent as a method to iteratively guess uh, the, the truest parameter values uh, and reduce the loss. So we are dealing with a simple linear regression problem of the form y equal to wx plus b. It is said that in linear regression, we try to find the best fit line. So here we're trying to model this function, and this function happens to be the equation of a line. So we're trying to find a model that best fits this function, and hence best fits a line. So we import a few Python libraries, such as math and matplotlib. Matplotlib is essentially a data visualization tool in Python and helps us use visualization methods such as scatter plots and bar charts. So what we're doing here essentially is that we have some ground truth x values and we have some ground truth y values. So x's are your inputs and y's are your outputs. And what we're trying to do is find the relationship between this x and y in the form of w and b, because the relationship we're trying to model is y equal to wx plus b. So here w and b are your parameters. So given this sort of data set or small data set to work with, we are essentially going to try different values of w and b. We are going to calculate this. We're going to calculate our estimated y values with our w and b and see how it varies from the actual ground truth. So we can go ahead and run our cells. So here we see that the real y, which is the ground truth, are these values, and our predicted y's are slightly off. So we can go ahead and visualize this loss. So here, essentially what's happening is the green dots are our predicted values and the blue dots are the actual ground truth values. So we see that our guesses are sort of growing at a faster rate than the actual y values. And these red lines correspond to the difference between the y values, the ground truth y values, and our predicted y values for each value of x. And we use Matplotlib's APIs to do this. For this, for example, this parameter essentially is finding the minimum. It could be that our predicted value is lower than the actual value, so the minimum of the two, and the maximum, and the third parameter is the maximum, and we draw a red line between the two. So now that we know, we can visually see that there is a difference between the ground truth and our predicted y values. We can also give it a quantitative value. So here we are using RMSE. So the first thing you can think of how to quantify this loss for each x value, or for the entire model, my bad, is to average out the differences. So you could take the difference of each y value, average it out, and that would give you sort of like the mean difference or the mean loss of this model. But like I said before, our predicted values could be lower than the actual values, and this would give rise to negative losses. So if you just add them up, they would cancel out, and this wouldn't give a true representation of our actual loss. So a method here would be to square the differences and then find the mean. And then we take the root of that to get back to sort of the same order of numbers. So we're essentially taking the differences for each value between the actual and our predicted, squaring them, adding this value, meaning it. By that, I mean dividing it by the length or the number of samples we have. In this case, it's 6, and then finding the square root. So we see that our loss is around 3, which is not too bad sometimes, but in this scenario, since our model is extremely simple, this is a bad loss. So we can go back and change our values. So the ground truth here is actually 2 and minus 1. So the data that we have represents 2x minus y equals 2x minus 1. So if we go ahead and run that, we see that they're exactly the same. And we don't see any red lines. And the loss is 0. So this is how, this is sort of like a manual way to tune your W and B parameters to reduce the loss to 0. But this would not work when the problem scales up. So we need a sort of like iterative method to minimize this loss. So that is what we will be exploring in this section. So what we're going to do is we're going to train our model. And this training essentially has 3 parts for this simple linear regression model. We have to define our model itself. We have to define our loss function. That's going to get the difference. It's sort of like give a measure of how off our predicted y values are from the ground truth values. And the training procedure, the method and how we're going to minimize this loss. So first, let's look at our linear regression model. We initially have, we define a W and B value. And in this case, we can just put them both as 10, but we already know that it's 2 and minus 1, but we're just going to put some random value. We're going to define a class, which is essentially going to be our model. It's going to take these W and B values and return Y. So how this works is whenever you call the model on a sample input value or a sample X value, this is going to return the predicted Y value, which would be WX plus B. Next, we move on to the loss function. Here we use the MSE loss. So we essentially take the square of the predicted and the target, and we take the mean of that. Reduce mean is a TensorFlow API that essentially just reduces the input tensor along a specific axis. So yeah, so this is our loss function. Next, we move on to our training procedure. Now here we're going to use this optimization algorithm called gradient descent. And here we define this train function, which essentially performs one step of gradient descent over all our x's and all our y's. So what we first do is that given our model and given inputs, which is our x values, and given outputs, which are our ground truth y values, we calculate the loss. So we perform model of inputs, which gives us our predicted outputs, and then we calculate loss between our predicted outputs and our ground truth value outputs. After that, there is some sort of calculus that's involved in the whole backpropagation procedure, where you calculate the gradients of our loss with respect to each of the parameters that we need to estimate. In this case, it's W and B. There is this TensorFlow API called Gradient Tape that takes care of all these calculus calculations behind the scenes. So we do this, we get our gradients DW and DB. And with these gradients, we are now updating our or the previous predicted values of W and B. So this is essentially the formula that takes place. So the weight is subtracted with the gradient into a scaling factor called learning rate. Learning rate essentially determines how fast your each step is, or how big each step is towards the from your predicted value of W and B to the actual ground truth value. So if it's really big, it might overshoot sort of like the local minima or the actual value. If it's too small, then it would take too long to converge to our actual values of W. So learning rate is a very important hyperparameter in neural network training. Yeah, so this is our train function. It returns our loss, but essentially what it's doing is calculating gradients and updating our W and B values. Next, so let's go ahead and run these. Okay, now that we have those three subparts ready, we're going to train our model and we're going to combine those three definitions. So first thing we're going to do is, again, define our mini data set. So essentially 6 values of inputs and corresponding outputs. We're going to define a learning rate of 0.14. Next, we're going to instantiate our model. So create basically an object of our model class. And we're going to do this, perform this training procedure for a fixed number of epochs. So in this example, we run for a fixed number of epochs, but there are more robust ways to determine when to stop training. So here we define epochs as 50. For each epoch, basically, we perform one step of gradient descent through all our X and Y values. And then we collect the history of our W and B values and our loss values to just see whether our W and Bs are converting to the actual value and how the loss decreases. So for every step, we essentially run this train function, which is calculating the loss between our predicted Y values and the ground truth Y values. And using that loss, it's calculating the gradients and updating our W and B values. So this happens iteratively. So let's run the cell. Yeah, so epoch 0, we see that W and B are 10, which is our initial, we define that. And our loss is pretty high. And then as we go through more and more epochs, we see that it eventually converges to 2 and -1, which are our ground truth values. And the loss reduces to 0.00, effectively 0. So now if we go ahead and plot this, we see that, so the dotted lines represent our ground truth value of W and B, which is 2 and -1. And our estimated values of W and B as we go through multiple epochs eventually converge to the ground truth values. So this is essentially a simple training procedure used to iteratively guess the parameters of the function.